Okay, it's 7 o'clock and we'll go ahead and get started. Let me make sure you can hear me. Can you hear me? Yep. All right, I heard myself. So great. So again, my name's Tony Edwards, and I am the warning coordination meteorologist here with the National Weather Service in Charleston, West Virginia. So my job is mainly to do outreach, and weather spotter classes is a part of that. But I'm basically the principal interface between the Weather Service Forecast Office and our users. So every spring we do a push to do weather spotter classes and get spotters trained up, and we're going to talk about why that is. But of course, this year with COVID, everything has to be done virtual, and so this is our last scheduled class of the spring. So thank you for joining us. And I see some familiar names on. I noticed the registration list. We've got folks from all over the region that have registered, and so that's great. First, a little housekeeping. As if you're not familiar with GoToWebinar and how it works, you have a window, should be over on the right side of your screen. If you don't see it, there should be a little orange arrow that you can click and it'll expand the menu out. But if you're having a hard time hearing me, then you can click on phone call, and that will give you a phone number that you can call in and at least listen to the presentation. So I do always want to bring that up if you are having audio issues. And then there's a little questions box down here. So if you have a question at any time, type in your question into that box, and what we'll do, I'm running this solo. Typically I have somebody that handle the question and answer part for me, but I'm doing this solo. So what we'll do is we'll take a break about halfway through, and I'll answer any questions that pop up. And then at the end, I'll have an opportunity for you to ask questions as well, or I'll answer questions that have been typed into the box. So just remember that if something I say kind of triggers a question in your mind, type it out there. May not get to it and right away, but during those question and answer segments, we'll get to that question. So remember that. So all right. So, and the last little bit of housekeeping here. A lot of information in this presentation. We're going to talk about a lot of web pages and reference a lot of websites. So if you've got a pen and paper, that's great, jot those down, but you don't have to worry about, what did he say, what website was that, what was the URL, because we have all of these sites linked on our weather spotter page. You get to it from weather.gov/RLX/weather-spotter. And so on that page is more information about what it means to be a spotter, and a calendar of weather spotter classes. And we also have a way for folks to watch a recorded webinar and become trained. We have the slides from the presentation today on there that you can download in PDF format, so you can keep that. We also have a Weather Spotters Field Guide, which is a handy document you can print off, and it's really a good reference material for spotters. And we have a cloud chart on there as well. So these are all resources for you, along with links to all the web pages and references that I'm going to talk about during the presentation. So this is all on our weather spotter page, and so there you go. This will also be an interactive presentation, and I've got some little poll questions sprinkled throughout the presentation. So let's try our first poll question just to get a feel for this, and let's see how this works with you all. And what is your favorite kind of weather? So on your screen, there are several different types of weather. You vote and tell me, what is your favorite kind of weather? What do you think? Okay, we've got votes coming in. Great. So far, we're about split evenly. I'll give it another second, see if anybody else wants to vote. What is your favorite type of weather? So we're pretty evenly split. I'm going to close it out and we'll take a look at it here. Share it. So we're pretty evenly split between rainy day, sunshine, and warm temperatures, and I'm a weather weenie. I like all of it. So I always like to see how this varies amongst the webinars that I do, and it seems like the earlier ones I've done this year, people really like thunderstorms or snow. So nobody on this one likes either one of those. So, but anyway, that's how this is going to work. I'll share these throughout the presentation and give you a chance to be interactive and answer the question. So let me hide that. And I've also noticed that based on feedback I've gotten, that sometimes there's some videos in here, and sometimes, especially if my webcam's up, it seems to cause those videos to be slow or clunky if on people that don't have really high-speed internet. So now that you see my face, we've introduced each other. I'm going to go ahead and close my webcam out, and I'll open it back up when we go to the question and answer session. So let me do that here real quick. If I can find the right button. There we go. Okay, so let's get into the presentation here. And here are the objectives for our class. So at the conclusion of this course, you should be able to describe your community's severe weather threats. Understand the role of a weather spotter and how important they are to National Weather Service operations. Properly define a severe thunderstorm and identify basic thunderstorm structure and clues to tornado development. And hopefully by the end of the class, you'll be able to provide accurate and timely reports of severe weather that'll increase the weather readiness of your community. As a weather spotter, what you do is a really valuable community service. And then we'll talk about weather safety and how to implement a weather safety plan. So that's where we're going. That's some of the topics we're going to be talking about. Here's our different sections of the class. We're going to start out with lessons from the past. So I really enjoy history. I wish I'd have paid more attention to it in school, but now that I've lived in this region. I grew up in East Tennessee. I've lived in Eastern Kentucky or West Virginia now for about 15 years working for the Weather Service. And so I've gotten a really good background understanding of the weather in our region. And I really love this quote from Winston Churchill: "The farther backward you can look, the farther forward you're likely to see." So basically, in other words, if it happened in the past, there's a good chance that it is going to happen again in the future, and we need to prepare for it. So I always like to start my presentations with a look back at the past and look back at some of our weather history. And of course, here in West Virginia, Southeast Ohio, Eastern Kentucky, Southern Virginia, the region that we forecast and warn for here in the Charleston Weather Service office, floods are our primary concern, and our biggest weather disaster usually revolves around floods. And so here's a typical scene, community comprised of quite a few mobile homes next to a creek here, and this was taken in Eastern Kentucky a few years ago. And torrential rainfall, thunderstorm sits over this area, dumps 3, 4, 5 inches of rain in a very short period of time, and the creek becomes a torrent and washes these homes away. And so this happens all too often in our region, and it is our region's biggest weather threat. And flooding kills more people than any other weather disaster in our region, and most people die trying to cross flooded roadways. And so when we look at the flood statistics, these are the counties that we forecast and warn for in our service area. And on the map on your left, and you can see highlighted in each county are the number of flood deaths that have occurred since 1990. And if you stretch this back further into the 80s, all those counties in the northeastern part of our service area, say Harrison County and Barber County, they fill in with deaths from the 1985 flood, which happened when we don't have as good a documentation for the flood deaths there, but pretty much our entire region's untouched by floods and flash floods. And so you can see on the pie chart in the upper right, most deaths occur in a vehicle, people driving into floodwaters, and it's certainly something that happens all too often. And then most of those, the majority of them, happen at night. So over 50% of those flood deaths occur at night. So that's a recipe for disaster. A flooded roadway at night, you can't see, the visibility is not that great, and so you don't know the depth of the water. But then you also don't know how the condition of the road underneath. Maybe that road's been totally undermined and washed away, and you drive into that water thinking it's just not very deep, and then all of a sudden the road's gone. And so that happens again all too frequently. There's two charts on this slide. The first one on the left shows the the flash flood events and the flash flood days per month. So the events are in blue, and if you have a day that has at least one flash flood, we count that as a flash flood day, and that's in red. So Both trends, of course, they go up in May, June, July, and August. That's kind of the peak of our flood season, so to speak. But we have floods and flash floods every month out of the year. So even in October, typically the dry season here in our region, we've had floods and flash floods occur then. And then on the right is the number of flash floods per time of day. And so you can see that again, our floods and our flash floods peak in the mid to late afternoon into the evening hours. However, many flash flood events occur during the overnight hours. You can see those flash floods occurring, after midnight and before dawn. Those are the ones that are really troublesome, and that really, that's why it's really important to have an alternate way, or a way to get woken up by weather alerts that we issue. And especially if you're in a flood prone area, have that. Of course, the cell phone, we'll talk about wireless emergency alerts. The cell phone will alert you if we're expecting considerable or catastrophic flooding in a flash flood warning. But then it's always important to have redundancy, and a NOAA weather radio is a great thing to have to back up the cell phone. So here's one of the floods, kind of touched on this before, the Election Day floods in November 1985, one of the worst disasters in our region on record, really. And you can see some of the statistics here: 3,500 homes, 180 businesses destroyed, with 6 to 10 inches of rain that fell in the West Virginia mountains and then flowed down the rivers and tributaries, and just caused a lot of damage. $500,000 in damages, which adjusted to today's dollars would be over $1 billion in damages. And unfortunately, 47 people were killed. And you can see some of the images from Philippi of the flooded town there. So just a tremendous disaster. Here's another one that occurred a little more recently, and especially folks in West Virginia may remember this one from the June 2016 floods. And you can see on the left, again, the video, some of you, if you don't have the best internet, it may be a little choppy, but it's showing these thunderstorms, and they just continually develop and pass repeatedly over the same location, and just drop a tremendous amount of rain. You can see the Lewisburg Airport here, the trace of rainfall, and how that just climbed upward, especially as this one round of thunderstorms moved over. And I'll show you that right now in just a minute. Multiple rounds. Here comes the big one, though, and just passed repeatedly over the same location. And the airport ended up getting 3.69 inches of rain in 2 hours after already getting an inch of rain. So that saturated the ground, and then the 3.69 just sent everything into flood. And here's the result. You can see just some tremendous flood damage in the White Sulphur Springs area of West Virginia. But this was repeated from basically Kanawha County over into Greenbrier County, and then over into Virginia as well. So a really bad flash flood event. 23 deaths were associated with this flood. So that's floods and flash floods, and we also have believe it or not, we have a rich tornado history in our region. Sure, most people think of West Virginia, you think of floods, but you also need to think about tornadoes, and that's why we're going to spend a considerable amount of time talking about tornadoes in this presentation, and what you need to know about as a spotter to help us know that these are occurring and are on the ground. So in the counties that we forecast and warn for, we've had a total of 158 documented tornadoes. Now, if a tornado touches down in the middle of the woods and nobody's around to see it or hear it, does a tornado touch down? Well, yes, it does, but we don't know about it. So keep that in mind. There's been a lot more tornadoes develop and touch down than we know about. But you can see on the map here all the tornado tracks. The most in any one county, and I keep forgetting to update this slide, but it's actually Perry County, Ohio, now has 13 tornadoes after a recent one in the past year or so. The earliest tornado on track, May 12th, 1886, and that's over here in Meigs County, Ohio, where we had an F4 tornado. Very strong tornado touchdown and do damage there back in 1886. The longest track tornado on record in our forecast area was this one. So this is known as a West Liberty tornado. It actually just really destroyed the whole town of West Liberty, Kentucky on March 2nd, 2012. It tracked from Menifee, Kentucky through Lawrence County, Kentucky, Wayne County, and the Lincoln counties in West Virginia before lifting. So a total of 86 miles. that was the longest track tornado in the entire country in the year 2012. So pretty remarkable stuff, especially considering that you know, tornadoes don't normally happen in that region. The strongest tornado on record, an F5, over here in southeast Ohio. So this tornado touched down near Greenup, Kentucky, tracked across the Ohio River, and devastated the town of Wheelersburg, Ohio, before it tracked through Lawrence County into Gallia County, Ohio. That was an F5 tornado, so the strongest tornado that you can get. And then the deadliest tornado was the Shinston tornado back in 1944. This was an F4 tornado. It killed 100 people and injured 381 up here in the northern part of West Virginia, in an area where tornadoes aren't a regular occurrence. And I can remember reading some of the documentation on this tornado, and folks really didn't know what it was coming at them. They could see the cloud, they could see it, just they had no way of knowing what it was. Of course, the warning system wasn't what it is today, no radar or anything like that. So caught a lot of people by surprise, and they really didn't know what it was. So we do have a rich tornado history in our region. And we talked about the F scale a little bit. I'm going to dig a little more into that so you have a good foundation under what we're talking about. The F scale stands for Fujita. Ted Fujita was a tornado researcher years ago, and he developed the Fujita scale, which was abbreviated F scale. And then along about 2007, that scale was redefined and enhanced, so to speak. And so that's why we call it the EF scale now. But basically, it's a 6-tiered scale of tornado intensity. So when a tornado happens, we don't know how strong the tornado is. You know, we don't have instruments measuring the wind speed at the ground level. Now, our radar will estimate wind speeds in the aloft in the rotation, but you know, if a tornado hits a weather station on the ground, more than likely it's going to destroy it. So what we have to do is, after the fact, go in and take a look at the damage that that tornado has caused. And then looking at the damage, we have this the EF scale that gives us an estimate of the wind speeds. And so we can determine how strong that tornado was based on a lot of research done in the damage that's caused by it. So typically, most of the tornadoes we get in our region are EF 0s and 1s. They have wind speeds of 65 to 110 miles per hour. They're short-lived. They track generally less than 3 miles. They develop quickly and occasionally without warning. So a lot of times these tornadoes develop, and there's really no clear signature of them on radar. Then you get up into the EF2s and EF3s, and that's wind speeds of 111 to 165 miles per hour. Those are much longer track tornadoes. They're much better detected by radar. And then you have the EF4s and EF5s, and so that's 166 to 200 plus miles per hour wind speeds, and really long tracked and can last over an hour, and they develop from well-organized supercell storms. So that's your EF scale, and that'll come up a little bit more throughout the presentation. So when it comes to tornado history, again, each county in our service area is identified on the map on the left, and you can see that Perry County, Ohio is our leader as far as tornado numbers go. Washington County, Ohio, second. Kanawha County, West Virginia, third with 11. And then the strongest tornado by county is indicated on the map on your right. And I will advertise our natural hazard risk assessment webpage. The link's at the bottom. Also, it's on our weather spotter page that I referenced earlier. But that is a great resource for a lot of different climatology when it comes to weather extremes in our region. So if you want to know what the coldest temperature it was in your county, you want to know how many tornadoes you've had, you want to know how many floods you've had in your county, you can go to that webpage and look up this information pretty quick and easy. So that's available for you. And then here's the Wheelersburg tornado that we talked about. Here's one of the graphics from that, the pictures from that, courtesy of the Portsmouth Public Library. But again, this tornado was nearly a half-mile wide at one point as it tracked 45 miles across the Ohio River into southeast Ohio. 7 people were killed in Scioto County, Ohio, with 108 total injuries from this storm. And all those deaths were in and around Wheelersburg, Ohio. And then when it comes to tornado climatology, and you can see the graph on the left is the months of the year, and then the graph on the right is hours of the day. So we are heading right into tornado season in our region. Typically they peak in May, June, and in July. but April is heading in that direction as well. So we increase basically from now through the month of June. And then for the hours of the day, again, like the flood climatology, most of our tornadoes occur during the late afternoon and early evening. However, we also have had some tornadoes that develop during the early morning hours and late at night. These are the ones that are really worrisome, just like the floods. You know, that's why it's very important to have a way to get those weather alerts in the middle of the night. Okay, so let's go to our next quiz question. So here we go. Most flood fatalities occur when people what into floodwaters? What do you think? Okay, got some votes coming in. Okay, so we'll go ahead and close it now and share the results. Everybody got it right. Very good. Most flood fatalities occur when people drive into floodwaters. So excellent. Okay, so let's move on now, and we will start with section number 2, the role of a weather spotter. So why in the world do we teach weather spotters? Why do we need weather spotters with all the technology that we have nowadays? Well, we'll get into that. First off, I want to lay out some guidelines as far as being a weather spotter. Safety, safety, safety. Safety is the #1 priority. So if it takes you 10 minutes to get a report to us because you are getting yourself to safety, your family to safety, that's okay. We want you to report severe weather when you can do so safely. We're going to talk about when to contact the weather service. Have that in mind. You know, refresh yourself on that before the severe weather events. Stay calm, be specific, don't exaggerate reports, and never give out the weather spotter phone number. So the way this is going to work is after the class is over, about an hour after we're done, you'll get an email. And in that email from the GoToWebinar folks will be a link. There'll be several links in there, but one of the links will be to a Google form where you can input your contact information. So we have a spotter database. We have a database of all the people that we've trained, and we can actually overlay our spotter network over our radar. So if we have a storm go over an area and we're not getting reports, we're not getting any information from that area, we'll actually sometimes reach out to our spotters or contacts in that region. So you give us that information, your phone number, your location, and then we will turn around and give you our 1-800 weather spotter number. And so that is the number you can call 24 hours a day, 7 days a week to pass along severe weather reports. But we do ask that you keep that, internal. Don't give out that number because it is unlisted. Don't give that number out to just anybody. That's just for giving out to trained weather spotters. It's important that you understand that we're training you to be a spotter and not a chaser. So I'm sure many of you watch the chasers on TV. And one thing we're never going to do is call you and ask you to go out and chase a thunderstorm. If you want to chase on your own time, that's fine. It's up to you. But what we want you to do is just spot, which is basically tell us what's happening where you are. It's very dangerous to chase in our region because of the terrain, the hills, the mountains. They really limit our visibility and they make storm chasing very dangerous here. So again, it's not recommended. What you do in your own time is up to you, but we're never going to call you and ask you to chase a storm for us. But what you do as a weather spotter is a very valuable community service. So you can see what we do on the left, and I typically, this guy's got more hair than I do. What I basically tell folks that we do is play a video game at our office. So we're sitting at the computer screen and we have all these images in front of us depicting what's going on, but we don't really a lot of times perfectly understand what's going on at the ground level. We rely on people, we rely on spotters and weather observing equipment to give us really kind of a better idea of what's going on at the surface. So us issuing these warnings, looking at the radar data, and you feeding us information on what's going on in your community we put those two together, and that helps us deliver a credible warning and gets people to acting. So again, what you do helps us, but also helps your community. So again, I work for the National Weather Service, and I always want to talk about this a little bit because usually when I tell people I'm a meteorologist, they ask me what TV station do I work for. And so then I have to explain that I'm not on TV. But what we do is issue the forecast and warnings for our region. And basically, if you get a weather warning, whether it's through the media or whether it's over your phone, that comes from your local National Weather Service office. So that's our bread and butter. Yeah, we forecast. We're there 24/7 issuing forecast, hydrologic information, climate data, but our bread and butter is issuing those warnings for the protection of life and property. And this is our forecast and warning area, 49 counties in West Virginia, Ohio, Kentucky, and Virginia. And it's a very diverse area. So we forecast anywhere from 495 feet elevation in Greenup County, Kentucky to almost 5,000 feet in Snowshoe, West Virginia. It's a very difficult area to forecast for due to the terrain that we have. So, but this is our area that we are directly responsible for. And there are 122 National Weather Service offices like ours that all have a little piece of the puzzle that makes up the United States and our National Weather Service. And so anywhere you go, you have a Weather Service office responsible for your area. So our primary tool is radar. And this is what our radar looks like. This is if you go to South Ridge in Charleston and you look up behind Cabela's on the hill, you'll see what looks like a soccer ball sitting on a pedestal, and that's our weather radar. And inside that dome that looks like a soccer ball is a satellite dish, and it's really large, and it rotates 360 degrees, emitting a weak beam of electromagnetic radiation that when it hits a raindrop or a hailstone or a bird or a bug or whatever it may be in the sky, signal is reflected off of that object, and the satellite dish picks up that signal and turns it into a pretty picture that you're used to seeing on your phone, so or on TV. Now, unfortunately, the radar has a limitation, and the limitation is that the farther you get from the radar, the higher up in the sky is the radar beam. And so within about 40 miles or 50 miles of the radar, we have a pretty good view of storms. Once you get beyond that, then our view of storms and view of the atmosphere goes down quite a bit. So in this particular instance, you see the path of energy here from the radar. And again, it's going upward a little bit. So the farther you get from the radar, the higher it is up in the atmosphere. And so we are missing out on this tornado. Now, we're probably able to view the velocity image and see the rotation in this storm, which would extend pretty high up in the storm. But we're not physically sampling the tornado itself. So that's where you come in to let us know that that's on the ground, that you're seeing that rotation, that you're seeing that damage. And we have a dual pole radar. Dual polarization means that basically we're not able to just see the horizontal, we're also able to see the vertical when it comes to, the hydrometeors. So if a hailstone is large, we can detect that with our radar. We can't tell exact sizes, but we can definitely tell large from small, and objects that are wider than they are taller, like a raindrop. When it's falling, it's actually wider than it is tall, and so we can kind of pick that up with our radar. All kinds of interesting things that we can view from our radar. And here's what our radar gives us back. So it gives us back reflectivity, which is the location of storms, the intensity of storms, and the movement of storms, which you're used to seeing. This is commonly shown on the TV media and cell phone apps and whatnot. We also get velocity imagery. Velocity is a little tougher. And I had some advanced classes earlier in the spring that we talked a little more in depth into velocity, but it does take a trained eye to be able to read velocity because basically it's showing you objects that are moving away from the radar and in towards the radar. And so you have to kind of orient yourself to the radar and then realize what color you're seeing and then the intensity. So it takes a little harder to understand than reflectivity. But basically it's able to tell us if the storm's rotating. And if a storm is rotating, then that storm can easily become severe. And so that's what we look for. But again, what you do is integral to our warning process. So the public's more likely to heed a National Weather Service warning when an actual report has been confirmed. And so what we do is typically we issue warnings, and they're based off radar. And so the warning will say Doppler radar indicates a tornado on the ground 5 miles west of your town. But when we get the actual observed report, or maybe there's hail falling and a spotter reports hail, or flooding occurring and a spotter reports flooding, we actually put that flooding or that tornado or that hail's been spotted by a trained weather spotter or emergency management or police or whatever. And so that information gets put directly into the warning. And so then people hear that or read that and they know it's actually occurring. And so your ground truth plus our warning equals public action. And it really gets people to seeking shelter and saves lives. Now, there's a lot of different ways to report to us, and they're all outlined on this webpage that you can access anytime, including some information at the bottom. You can click on these tabs and get more information about what we need to look for and how to report it. But basically, we have several different ways you can report, and we're going to look at each one of them. The best way is our 1-800-SPOTTER hotline number. Again, this will be provided later if you fill out our spotter database. Basically, you tell us when you call us, all we need to know about is who you are, and you can tell us you're a trained weather spotter. Tell us what weather is occurring or has occurred, when did it happen, and where did it happen. So who, what, when, and where. And real-time reports are crucial. However, even if it's not real-time, maybe you've been at work all day and you come home and see trees down on your property from a storm that occurred earlier in the day. That's okay. Let us know about it. Tell us what happened. And we'll figure out what time it happened based on radar. But all those reports are extremely valuable to us, and especially if it's a tornado or flooding, something life-threatening, please call us. That's the best way to get your information to us, because we'll answer quickly 24/7. It'll ring straight through to a forecaster, and we'll be able to ask you questions, get more information from you on whatever you're wanting to report. Now, hopefully, at least one or two of you on here have heard of Facebook before. Maybe you've used Twitter. It seems like Facebook's more popular than Twitter in our region, but we use both of them, and we monitor both of them during severe weather events. We have somebody actively monitoring social media to get reports. So, if you've got something going on, you get trees down, hail falling, take a picture of it and send it to us. Now, if you do use social media to send us reports, please make sure your location is evident in that post, because sometimes, especially if you've got your privacy settings really locked down, it's hard to tell your location. So always include your location. Towns is fine. You don't have to drill down to the exact address if you don't want to, but at least let us know what town you're in and where the severe weather occurred. We also have a kind of a new feature, a storm report form. And so it's available at inws.nsep.noaa.gov, the address at the bottom. It's also, again, linked on our Weather Spotter page. This is available for PC, and it works on a mobile device as well. And the great thing about this page is it doesn't matter which office you're reporting for. This can work for any office. You just submit your report, and it automatically routes your report to the appropriate National Weather Service office based on your location. So this is really great for long-haul truck drivers or those folks that travel a lot, and maybe you can't keep up with every 1-800 number for every office in the country. You can submit your report here, and it'll automatically be routed to that office. Or, of course, every office is on Facebook and Twitter as well, so you can follow them there and send reports. Either way, what works for you. And then this app is also a great little tool. You can go to your app store on Apple or Android and search for MPing, M-P-I-N-G, and it'll pull up the simple app that basically allows you to send us a weather report with just a few clicks on your phone. And so you select your report type. You can send us rain and snow reports, hail reports, wind damage. You can report a tornado using this app, although I'd much rather you call us and report something like that. Floods, landslides, reduced visibility, all that can be reported using the MPing app. And this is really handy in the winter. Our region, we are always on that dividing line, it seems like, with winter storms about who gets rain, who gets freezing rain, who gets sleet, who gets snow. And so we can have it all going on in our forecast area at the same time. And it's very valuable information to get these ground truth reports from our spotters, from weather enthusiasts that want to let us know whether it's raining or snowing or sleeting or freezing raining in their backyard. So please use this. Let us know what weather you're getting. Really helps validate our radar information and helps us really know what's going on in your community. And so please do that. Now, what I'm going to talk about next, really near and dear to my heart. I've been a CocoRaHS observer for since 2008, and CocoRaHS stands for Community Collaborative Rain, Hail, and Snow Network. So it's a network of volunteer weather observers that make an obligation to purchase one of the rain gauges. That it's a standard rain gauge, so everybody's using the exact same equipment. It's studied and researched, and a very accurate gauge. And you just manually measure the rain and snow every day. And so every day about 7 o'clock, I go out and measure my rain. And I send the report in on my smartphone. It's an app that allows you to send it in really quickly and easily. So very valuable information to us. You know, we've got a lot of automated equipment out there. We monitor what's called iFlows gauges. These are rain gauges put out by the states and just in locations, and they transmit their data about every 15 minutes. We get their data. We've got networks of rain gauges all over the place. We also monitor Weather Underground. If you have a weather station and you're submitting your information to Weather Underground, we see that. But all these automated equipment, all this mechanical equipment like tipping buckets, they have their flaws. And so we still need human beings to just manually measure the rain and let us know that every day. And we take that data and we check everything else based on that rain gauge data from our CocoRaHS and other volunteer weather observers. So if this interests you, if you measure the rain already, why not do it and professionally and you know, get it to us daily, and we'll use it. It's very simple. You just go to cocorahs.org, look for more information. You obtain one of these 4-inch rain gauges. They're 4 inches in diameter. They have a tube in the middle that measures up to 1 inch of rain very easily. If you get more than 1 inch, it'll overflow into the outer tube. And these gauges will hold up to 11 inches of rain. And then there's a training slideshow. We also use CocoRaHS observers to measure snow. You know, we don't have any automated equipment to measure snow, so we actually rely on human beings to do that. So CocoRaHS helps us there. And snow can be a little hard to measure sometimes, so there's training available for that. And so you set the gauge up in a good location in your yard, and you start observing precipitation and reporting online daily. It's that easy. Very easy, but very important information for us. And we're always trying to grow our CocoRaHS network. In fact, March, they have a little drive to get folks signed up. It's called March Madness, goes along with the basketball tournament. And so we try to see which state can sign up the most observers. So I'd love, you know, if you are interested to sign up for CocoRaHS, help us out there. But here's what we need you to report. If you see any of these things, please report as soon as you can. Tornadoes, funnel clouds, wall clouds. If you don't know what a wall cloud is, just hang tight. We'll go over that. But basically, if you see rotation, if it spins, call it in. We want to know about hail. Any size hail you see, we want to know about it. Storm damage, trees down, that kind of thing. Flooding is a big one. Let us know about flooding if you spot it. Heavy rainfall. If you've got a rain gauge, you can measure 1 inch of rain in an hour. Let us know about it. That's a common threshold where we start to see problems. Wind damage and winter weather. We'll talk briefly about winter weather. Hopefully we're done with winter weather, but again, we do rely on spotters and people to measure snow for us in the winter to let us know what's going on. Okay, so quiz time. What do you think about this report? Is this a good weather spotter report? Hello, I'm a spotter in Ripley. I have marble size hail falling. It began 3 minutes ago. What do you think? Is that a good report? Yes or no? Okay. Reports are coming in. Okay, give it about 5 more seconds. Okay, let's see what everybody thought about that one. So we had about 40% say yes, 60% say no, it could be better. And the no's have it correct. So it's a pretty good report. I'll give you that. They tell me they're a spotter. They tell me their location. They tell me what's going on. They tell me when it even started. It began 3 minutes ago. But they use the term marble. And so marble is one of those terms that we usually have to ask for more information because there's different sizes of marbles. I know most people, when they report marble size hail, they're talking about the smaller size that's smaller than the size of, say, a dime or a penny. This size marble is not severe. So we would not need to issue a severe thunderstorm warning if you're reporting this size marble. We still want to know about it. It really helps us calibrate our radar and what our radar is telling us is going on. But we don't need a severe thunderstorm warning. However, if you're talking about a marble that's that big, size of a quarter, then we need a warning for that because quarter size hail or larger is one of the criteria for a severe thunderstorm. So keep that in mind. Try not to use the marble term. Use objects that are more common, like coins. You know, you get up above a $50 size and we start referencing like golf ball, pool ball size hail, baseball, softball. You know, we have had areas in our forecast area where we have had softball size hail reported in the past few years. So it does happen here. So, you know, use those objects as common objects. Most of the time when it's hailing, we had some hailstorms across our region a few days ago. Saw a lot of pictures just like this. A lot of different sizes of hail out there falling. So when you do see that situation, we want to know about the largest hailstone that you see. That's what's going to do the most damage. So that's always report the largest hailstone you see. Now, I don't have any questions yet in the question box. However, I've got a question for you. If you have a weather station, so you've got an anemometer on your roof to measure the wind, post it in the chat. Say, I have a weather station, or yes, or something like that. So I know I've got some people there. Let's see if anybody has an actual weather station at their house. I'm not seeing anything yet. Typically, when I do a class, at least 1 or 2 people have a weather station. I'm not seeing anybody posting that question yet. Okay, there we go. Richard Clemens has one. Okay, great. So Richard and I've got a weather station on my roof as well. We know exactly how strong the wind is because of the weather station that we have. If you don't have a weather station, that's great. That's okay. You know, you can use objects around you to estimate wind speeds, and this is called the Beaufort wind scale. And so based on the behavior of trees, which is something we usually have plenty of those around to watch and monitor, you can estimate wind speed. So say you have some branches breaking off trees, small branches smaller than the size of your wrist, and you're in this 39 to 54 mile per hour range. Now, once you get above about 55 miles per hour, that's when you can see damage to chimneys or TV antennas or shallow rooted trees being pushed over. And so this is where we start to really get worried, and this is our warning criteria. Once you get above about 58 miles per hour. Excuse me, I felt that coming. Oh. So 58 mile per hour wind is the criteria for a severe thunderstorm. And but again, if you don't have an anemometer to measure that wind speed, if you start to see damage to trees, shallow rooted trees being pushed over, you see large limbs bigger than the size of your wrist, not falling out of trees, then definitely call that in and let us know about it because that needs a severe thunderstorm warning at that point. And again, we're talking about healthy trees here. If you have diseased trees or it's really, really wet and the trees can be uprooted with less wind than that. But any kind of damage you get, let us know about it. Okay, so let's try our next quiz question. So you're at home and you observe golf ball size hail falling outside. What do you do first? What do you think? Okay, we'll give it a couple more seconds for people to vote. Okay, so far so good. Everybody's got this one right. So here are the results. What do you do first? Report it to the National Weather Service. Seems like every class always have one or two people say run and hide under the bed. And that's an acceptable answer too if you take a phone with you. So you can call and report the hail falling outside to the National Weather Service. So very good. Everybody got that one right. So very good. Okay, so let's move into section number 3. Let's talk about thunderstorms. And again, if you have a question, if anything pops into your mind, you want more information, a clarifying information on anything that I bring up, just feel free to post that in the questions box and we'll get to that. But let's talk about thunderstorms, including ingredients, the anatomy, different varieties of a thunderstorm. We'll talk about spotting concepts and cloud identification, especially. So when we talk about thunderstorms, in our region, typically we get between 40 and 50 thunderstorms a year. And not every thunderstorm is severe, so we've kind of touched on this already, but we define a severe thunderstorm as a thunderstorm having 1 inch or greater hail, that's basically the size of a quarter or larger, 58-mile-per-hour winds or more, or tornado. Now, tornado gets its own warning, tornado warning, but it is also one of the criteria for a severe thunderstorm. So 3 criteria, that's it. You know, lightning is extremely dangerous, but lightning is not one of the criteria for a thunderstorm. Less than 10% of thunderstorms are severe with hail, wind, or tornado, but every thunderstorm has lightning. And so Mother Nature has its own lightning warning, and that's thunder. So if you're close enough to a thunderstorm to hear thunder, you're close enough to be struck by lightning. Lightning is a gigantic spark, lots of electricity, not something you want to fool with. I just saw an article about a surfer, I believe down in El Salvador. Professional surfer was out working on her craft and got struck and killed by lightning while surfing. So it happens very, too often here in the United States as well. And so what we say is when thunder roars, go indoors. If you can hear that thunder, go inside, even if that storm seems like it's far away, because as you can see in the pictures here on the slide, is lightning can strike well away from the parent thunderstorm. And a lot of people call these bolts from the blue because they seem like they come from a blue sky, but they've actually, the parent thunderstorm is just so far off on the horizon you don't see it. And more than 50% of lightning deaths occur after the storm has passed. So, a lot of folks will, after it stops raining, they'll go back out and venture back outside if they were doing something before the storm hit. But you really need to give it about 30 minutes, allow about 30 minutes of time to allow that thunderstorm to move away from your area. And so wait about 30 minutes after the last rumble of thunder before venturing back outside. And here's some safety tips when it comes to lightning. Go indoors, stay away from windows indoors, and you'll be okay. Don't use a corded telephone or take a bath or shower. Lightning can strike outside and travel through the plumbing or travel through the cord of a telephone and zap you if you're on it. Now, cell phones are okay because they lack the cord. And if you're outside and you cannot get inside of a sturdier structure, get in a vehicle. Vehicles are really good storm shelters when it comes to lightning because it's not the rubber tires that protect you, which a lot of people think. It's actually the metal cage you're setting in. And so if you're inside the car or truck and lightning strikes it, you'll be okay. It'll be routed around you through the metal into the ground. As long as you're not touching any metal, you'll be fine. Okay, so another quiz question. So according to our definition, what makes a thunderstorm severe? You can check all that apply on this slide. What do you think? Okay, give it about 10 more seconds for folks to vote. What makes a thunderstorm severe? Okay, let's close it. Share the responses. So tornado, everybody voted tornado, damaging winds, and quarter-size hail, and that's correct. Those are the three criteria. Looks like we had some votes for torrential rainfall that produces flooding, and that's one of those things that typically comes along with a severe thunderstorm, but that's not one of the three criteria. But we would issue a separate warning for that, and that would be a flash flood warning. So very good answers to the questions. Let me hide that one. And let's talk about thunderstorm ingredients a little bit. So this is a basic level class. I usually spend more time on this in my advanced class, but I did want to bring up the 4 basic ingredients for a thunderstorm. And they include moisture. They include a source of lift, instability, and then vertical wind shear. So moisture is important. We typically don't lack moisture in our region. In the summer, it's warm, it's muggy. We get that tropical feed from the Gulf of Mexico and the Western Atlantic supplying the moisture. But then you need something to get that warm, moist air lifted up. And typically that's a cold front that moves into our region. It lifts that warm, moist air up into the atmosphere, and it starts to cool and condense into a cloud and a thunderstorm, and if conditions are right. But you also need instability. And that's cold air, pocket of cold air above warm air near the ground. And so just like a hot air balloon, that hot air balloon gets up lofted with that heat, and it's warmer than the air around it. So a thunderstorm's the same way. A cold front comes along, lifts up that air mass, warm, moist air mass upward into that cool air mass above. And so it takes off and rises like a hot air balloon and turns into a thunderstorm. So that's the 3 ingredients you need for a thunderstorm. And then you need vertical wind shear to get the really strong thunderstorms that can produce the tornadoes, including the massive tornadoes that we see. And in our region, we typically lack vertical wind shear because of the mountains. So the mountains protect us from that. However, situations just right, you can get all 4 of these ingredients to come together to produce the massive supercell thunderstorm. So there's 4 types of thunderstorms. They range from single cells to multi-cell clusters, multi-cell lines, and supercells. And as you go from left to right on this slide, the severe weather threat increases. So we're going to talk about each one of these, but spend most of our time on multi-cell lines and supercells. So here is a single cell thunderstorm, and there's a video playing here. Hopefully you can see it. But this shows a single cell thunderstorm life cycle. And so notice the billowing clouds over here on the right. This is an updraft from this thunderstorm. And a mature thunderstorm has an updraft and a downdraft. And so watch as this updraft kind of dies out over here on the right of the storm. And the thunderstorm, that's its fuel supply. So once that happens, the thunderstorm dies out. But these single cell thunderstorms are typically non-severe. They have a life cycle of less than 30 minutes. They can contain some small hail and gusty winds, but they're typically not a big deal. Multi-cell thunderstorms have a bigger severe threat. Mainly heavy rain. However, you can get damaging winds from these as well. And so multi-cell thunderstorms are just single cells that just keep developing due to some kind of trigger or something going on in the atmosphere. They just keep developing one after another, and they train one after another over the same areas, like we saw in that radar picture earlier from the heavy rainfall back in 2016, how those thunderstorms just keep passing repeatedly over the same area. So flash flooding's a big hazard from these multi-cell thunderstorms. But you can get downburst winds as well. And so what's a downburst? Well, one of our jobs when we do get damage reports from thunderstorms is to go out and look at the damage and first off decide if it is a tornado or just straight line winds. And so non-tornadic winds are often, we call them straight line winds or microbursts or downbursts. And so a microburst is an area of damage caused by straight line winds that's less than 2.5 miles across. And I'm going to show you a time lapse here of a microburst happening. So remember we showed you the single cell thunderstorm and how that thunderstorm has updrafts. Here's the updraft part of the storm because it's flat, it's dark, it's ominous, but there's no rain occurring underneath it. That airflow into that thunderstorm is going up. And then over here is the downdraft. You see the rain coming out of that storm. So a lot of times that updraft will collapse, and when it does, then you'll get this pocket of rain and wind that'll fall out of the storm, hit the ground, and spread out. So watch as this happens here in this time lapse. See how that happened? Notice how that hits the ground and spreads out. And it does so with a lot of force. Here's some images of a microburst damage. And notice this pine forest is leveled here from the microburst winds. And the microburst hit here, and notice how there's divergent in the tree pattern, in the tree fall. So here's the tornado damage. So a similar forest, but notice the damage from the trees, the tornado is wrapping around the path of the tornado. And then here you have some trees that are being sucked in the inflow of the tornado. So more convergence compared to the microburst, which is divergent. Now here's the thing, if your house is located where my mouse is pointing, does it really matter to you if it's a microburst or a tornado? No, it doesn't, because you've got problems either way. So that's why it's very important to treat the severe thunderstorm warnings that we issue, treat them very seriously, because it doesn't take a tornado to do serious damage, as you can see from this imagery. Now that's a microburst. The other term defined here is a macroburst. So microburst is micro, it's small. Macro means large, a larger area. So macroburst includes winds extending in excess of 2.5 miles across. And a lot of folks in West Virginia, if you were around in 2012, you remember a microburst. The derecho that came through the state, came through our region, affected Ohio, Northeast Kentucky, West Virginia, was a classic macroburst. It affected a gigantic area, and we'll show more about that in a minute. So moving on to multi-cell squall lines. So here's a squall line on your left, and you could see the storms oriented in a line and moving southeastward out of Ohio into West Virginia. These squall lines are typically have a more overall severe weather threat, including hail, wind is the big one, tornadoes and heavy rain are possible as well. So this is what we see on radar. This is what you might see on the ground. And this ominous looking bank, this wall of clouds moving towards you, is a shelf cloud. And it looks like a shelf. We'll show you another example here in a minute. It's even clearer than this. But this is the leading edge of the high winds coming out of that thunderstorm. And it forms a wall of clouds, a shelf cloud that will move off in advance. And you'll notice a lot of these little clouds hanging down on the leading edge. And a lot of people mistake these as funnel clouds or tornadoes. But always look for rotation. And so if you don't see rotation, you don't have a funnel cloud or tornado. So that's always important to look at. Here's another example of a really wound up squall line of thunderstorms. This is called a bow echo on radar. This is a term we use because it looks like a bow and arrow, a bow. And at the leading edge of this bow is where the heaviest winds typically occur. Here's another example of a shelf cloud, this time lit up at night. And you notice it looks like a shelf, the way it slopes back. And that's why we call it that. So the extreme case of shelf clouds, or excuse me, the extreme case of a squall line is a derecho. And we get derechos in our region every few years. Most people, we have to be very careful using that derecho term now, because when we say it, everybody thinks it's the 2012 derecho, and it's going to be, 80% of the state of West Virginia out of power, that kind of deal. But the derecho we had in 2012 was just an extreme case of derechos. Most derechos aren't this bad. However, they typically do have very, very strong winds with them, can have some tornadoes, heavy rain. Here's the derecho from 2012, the image as it's passing out of Ohio into West Virginia. Here's all the damage reports from that complex of storms. And so the derecho started around midday around Chicago, and by the end of by midnight it was out in the western Atlantic. So it was just hauling about 80 miles an hour across our region. And everywhere you see a blue dot here, these are damage reports. And West Virginia, there's a little donut hole over West Virginia where we don't have any reports, but that's only because nobody had communications to be able to send us the reports. Phone lines were down, power was out, and the reports happened. We just didn't get word of them. And here's an example of a shelf cloud. And so I want you to watch as this passes over. Notice how chaotic the clouds are. A lot of times people will see that and they will report a funnel cloud or tornado because of the motion of the clouds. But what I want you to really focus on when you think you see rotation is that it's about a vertical axis. And so if the cloud's just rolling around and is really turbulent, then that's just turbulent clouds. That's just a shelf cloud. But when you see that vertical rotation, counterclockwise rotation, then that is definitely something that we want to know about for sure. As a spotter, you do not need to report shelf clouds. They're just your warning from Mother Nature that strong winds are about to occur. And here's a side view of a shelf cloud. Here's the shelf. Notice how it slopes down and away from the oncoming thunderstorm and the rain there. So that's more about shelf clouds. Again, we don't need to know about them from our spotters, but that's just your clue that very strong winds are coming. If you do get damage from as the shelf cloud goes over and the winds occur, then definitely report that, please. But you don't have to necessarily tell us about the shelf cloud. Okay, so now let's talk about supercell thunderstorms. And these are the classic ones you see on the plains that the storm chasers chase. And this is the anatomy of a supercell thunderstorm, what you may see if you're out on a mountaintop somewhere and can see for great distances, or out in a flatter country out west, and or maybe even in Ohio. Parts of Ohio get pretty flat and you can see for a good distance. Supercells can bring every type of weather hazard with them when it comes to severe weather: hail, heavy rain, very high winds, and tornadoes. So this is what we see at our office when we're interrogating these storms with radar. Again, we've got reflectivity over here on the left, the location, the intensity of the precipitation. And a lot of times you'll see a little hook that develops on the southwest or west flank of these storms called a hook echo. And that's a sign that that storm is rotating. And of course, here's the velocity image, which I showed you before, talked about a little bit before. Greens show motion towards the radar, which the radar is over in this direction. So you got greens moving towards the radar, reds moving away from the radar. Definitely strong rotation in that thunderstorm. And here's what you might see on the ground as a spotter from this storm. And this shows the difficulty of spotting in our region because, yep, this is a no-brainer. This is a supercell thunderstorm. This is a rain-free base part of the storm. It's dark, it's ominous, there's no rain occurring underneath it. Here's a lowering, it's a wall cloud. And so that lowering cloud structure that's rotating. Now, you might not be able to see it. I don't know how good your bandwidth is or how smooth the video's flowing, but this is definitely rotating. But I can't tell if there is a tornado underneath it because I'm blocked by the trees and the hill here. So, you know, if you see this situation, call us and tell us what you know and what you don't know. That's all we ask for our spotters, is just tell us what you know. And you may be able to stay with it, hang with it. Maybe you get a little better location, or the storm will move away from the hill a little later on, and you can get a better vantage point of what's going on with this storm. Oh, I went too fast by that one. Let me go back here. Okay, so here is another example of a wall cloud. And this is a rotating lowering from a thunderstorm updraft base. And so this indicates a very strong updraft occurring here. And so you often get a wall cloud, well, before a funnel cloud or a tornado develops. Now, not all tornadoes occur from wall clouds, and not all wall clouds produce a tornado. But if you do see this, if you see this rotation, definitely call us and let us know what you're seeing. So here's a typical radar signature of a supercell, and you'll notice here the kidney bean appearance to the storm, and notice that hook echo on the southwest flank of the storm that we talked about. So if you find yourself located here where the black dot is, what's this going to look like to you? Well, that's where the hail is going to occur in the storm. So that's the downdraft part of the storm where large hail, and again, with supercells, you can have hail the size of golf balls, baseballs, softballs, or larger. The largest hailstone to occur in the United States occurred with a supercell thunderstorm, I believe in South Dakota, maybe Nebraska, I can't remember. But it was about the size of a cantaloupe. So, you know, massive size hail can fall out of these. Now, same thunderstorm. What if you find yourself down here where the black dot is, looking up to the northwest where this hook echo is here? Well, that's where the tornado is occurring. And so here again, you have the flat, dark, ominous looking part of the storm, the rain-free base. Here's the wall cloud, the lowering of the rain-free base. And there you have your tornado. And so now you can actually see it pretty good here. But again, if you're down in this valley, you might not even be able to see that. So what you see depends on your location and your vantage point. But definitely call that in. Let us know what you're seeing in your location. Now, a funnel cloud is just a tornado that hasn't touched the ground yet. And so one thing that's very important, if you think you see a funnel cloud, then make sure it's rotating. If you do not see rotation, you do not have a funnel cloud. You've got a highly technical term that we abbreviate SLC. It stands for scary looking cloud. That's all it is. But if you've got rotation, then you need to call us in. There's two questions you need to ask yourself if you see a funnel cloud or think you see a funnel cloud. Number one, is it rotating? And number two, where is it pointing? You know, here's a classic example of a funnel cloud. Yes, it's rotating. This is a still image, but I'll go ahead and give you that it's rotating. So yes, you can check the box by it's rotating. But then you got to ask yourself, where is it pointing? And look where it's pointing. Notice you've got debris being kicked up down here near the ground. So at this particular time, this is actually a tornado, because even though the condensation funnel doesn't reach all the way to the ground, the violently rotating column of air does. So here's some more examples of these SLCs, or scary looking clouds, or the technical term is scud clouds. They look ragged compared to a funnel. You know, look at this funnel, how smooth the appearance is. These will look ragged, and there'll be no rotation in them. So several examples here. You know, this one's really scary looking. You really have to look at this one closely to make sure it's not rotating. But they may look turbulent. You know, they may move up and down or a different direction than the parent cloud, but you got to look for the concerted rotation. Okay, go to our next quiz question here. So which of the following events, should they occur, should be reported to the National Weather Service? Check all that apply on this screen here. What do you think? Okay, got several votes in here. About 5 more seconds. Okay. So let's see what everybody said. So the results: uprooted tree after a storm, 100% said yes, that's true. Flooded road, yes, please let us know that. Rotating wall cloud, very good. Pea-size hail, I want to know about it. Yeah, it does not make a thunderstorm severe. It's not going to really cause any damage, but as a radar operator, the more reports I can get, the better, because it helps me calibrate myself with what the radar's estimating the size of that hail to be. So maybe that storm went over your location and radar estimated you should have got quarter size hail. Sometimes radar's off. And so you calling that in and I can match you up as right under the core of that storm is only getting pea-sized hail. That helps me know that I don't really need to warn on that strong of a storm down the road. It needs to be stronger for that day. So very important information. A shelf cloud, you don't really need to report. We'll take the information, but you don't have to report it. That's your clue that strong winds are coming. Okay, so very good. So let's talk about weather safety now. And let's talk about how we try to keep you safe for severe weather and how to come up with your own severe weather safety plan. As far as weather safety goes, it's very important to prepare and be aware of the weather forecast. Know and understand the weather forecast. Prepare disaster kits for all seasons. Identify shelter locations before the storm. You know, this week is Severe Weather Awareness Week in the state of Ohio. And last week was Severe Weather Awareness Week in West Virginia. And earlier this month was in Kentucky. So, now's a great time of year to kind of think about these things and think about where your safe space is in your house. Should a tornado warning be issued, or should that time come? When a watch is issued, if you hear you're under a severe thunderstorm watch or a tornado watch, then plan your day around the weather. And when a warning is issued, that's when you want to be able to take appropriate action. You don't want to have to think about it. You want to be able to go ahead and do it, implement that plan at that particular time. Now, a great source of weather information is our webpage, weather.gov/CharlestonWV. And there's a lot of information contained on there. I could teach a whole class just on information on our webpage. But the important part, you know, if we have a severe weather outbreak or a winter storm or something like that expected, we'll put important information up at the top of this page so you can click on it and get more information. There's also a map down here that shows our watches, warnings, and advisories. You can click anywhere in that map and get a detailed forecast for that location. If you don't know exactly where you live on the map, you can type in your city or town or zip code up here in this box in the upper left part of the page and click go, and that'll take you to a forecast devoted just for that location. Another way to get to that page is go to weather.gov/your zip code. And so what I've done here, I live in Hurricane, West Virginia, and so I've gone to weather.gov/25526. It pulls up this page. And you'll notice a map down here that you can actually zoom in and you can better define this. You know, zip codes are typically pretty big. And so you can find exactly where you live or your location in that area and bookmark this. So we don't have an app in the National Weather Service, a dedicated app. Get asked that question a lot, but you can actually bookmark this page and it behaves just like an app. So every time you pull this page up, it'll pull in the most current information for your location. So this is great to bookmark on your phone. And of course, we talked about Facebook and Twitter and then NOAA Weather Radio. Those are important to have, and we'll talk about that a little later on. But basically, we use a 3-tiered alert system to keep you apprised of severe weather. And so it starts off in the outlook phase, and you can go to the Storm Prediction Center's website, or oftentimes you'll see the TV meteorologist or our hazardous weather outlook from the National Weather Service talking about severe weather threat or other threats in the longer range, maybe 3-4 days out. So this is your cue to be aware. You know, if you've got something planned that day, just be aware that you might need to make some alternate plans, change your schedule. Now, once the event gets a little closer, say a few hours out, maybe we're expecting severe weather over our region, the meteorologist at the Storm Prediction Center will issue a severe thunderstorm or tornado watch. And so that watch box means the threat's increasing, but you've still got time. You've got several hours ahead to get prepared. And so, like I said before, when that watch is issued, that's when you need to plan your day around the weather. And then when a warning is issued, then that's when you need to take action. You need to implement that severe weather plan because severe weather is imminent. It's either been detected by radar or we expect it to develop really quickly, or we've had reports of that severe weather. So where to get outlooks? Well, again, you can go to our webpage, weather.gov/CharlestonWV, and then click at the little round, the little red box down at the bottom that says briefing or outlooks. Anywhere on the page will get you to our briefing page. And so this will have our hazardous weather outlook. and then a bunch of other information specific to each weather hazard that you can click on and get that more information. The Storm Prediction Center is another great website to go to during severe weather season to get the outlooks for severe weather. And they use a 6-tiered system to keep you alert for severe weather. It goes from general thunderstorms up to a high risk of severe weather. And this kind of tells you a little bit about what each of those means. But basically, this is just your way to maintain situational awareness of severe weather threats in the next, all the way out to 7 days into the future. Now, as far as getting severe weather alerts themselves, there's one way to get them that you don't even have to download anything for. And so if you have a smartphone, then you are already getting wireless emergency alerts. And so these are alerts built into your phone, basically a bell ringer to let you know if there's any kind of imminent threat to life and property, such as severe weather. They also use them in several states for Amber Alert notification. Basically, the message you get tells us what's happening, the area affected, how long, recommended action, and the alert originator. This says 90 characters. I think it's up to 280 now, or at least 140. I have to look that up now. I need to update the slide, but they recently updated these so they have more information available in them. And pretty soon they're going to be updated where they'll even be able to have hyperlinks in them, so you can click on something to get more information. But right now, the only thing that triggers these are, in our region, are tornado warnings and flash flood warnings that are issued for considerable to catastrophic damage. Pretty soon, we're going to have the ability to turn these on for severe thunderstorm warnings for extreme events like the 2012 derecho. We're going to be able to alert cell phones for those types of events, but right now, severe thunderstorm warnings do not trigger these. So if you want severe thunderstorm warnings and other types of warnings, you need a different app. You need to download something. And FEMA has a good app that allows you to select up to 5 locations to receive National Weather Service alerts for. And then the Red Cross app as well allows 35 different severe weather and emergency alerts. And it also has a lot of other tips and things like that on it, information. So these are 2 great apps. And then No Weather Radio, you know, any kind of app you have, or if you're relying on your cell phone, you need to have a backup, because what if the cell phone tower goes down? And that does happen. So weather radios are relatively inexpensive. They're programmable battery backup during power outages, and they can tone alert for warnings when not in use. So these are great to have as a backup severe weather alerting platform. As far as disaster kits, there's a lot of stuff on this slide. You can go to ready.gov/kit for more information on what to include in your disaster kit. But basically, the bare minimum is 72 hours worth of food, water, and medicine. And not only for you, but for your pets and loved ones as well. So whatever you need to get through at least 3 days without help from the outside world, that's what you need in your disaster kit. Now, with weather safety, when it comes to tornado, you know, what are you going to do if maybe you get home from work tomorrow, pull in your driveway, and you see this coming at you? Or maybe you go to town Saturday and thunderstorms are occurring and you see this coming at you. You know, what do you need to think about? Well, if you live in a house, you need to be underground. That's the only safe place to be in a very strong tornado, EF2 or greater. Now, again, luckily, we don't get as many of those in our region. Most of the tornadoes we get are EF0s or EF1s. And so the safest place to be, if you don't have a basement, is in an interior room away from windows and doors. So you want to get as interior to the home or structure as you can get and get away from windows and doors. And so that's your best option if you live in a house. Now, if you live in a mobile home, you do not want to be caught in a tornado. Mobile homes are not safe in tornadoes at all. You know, I tell people live in a mobile home or trailer that if the tornado watch is issued, that's your best time to go ahead and find someplace else. Go to a family member or friend's house that has a basement. You know, go to Walmart, go to McDonald's, just go somewhere else. You don't want to be in that mobile home, look out the window and see a tornado coming, because then the safest option is to go outside and lie down in a ditch or culvert as a last resort. But do not ride out a tornado in a mobile home. If you're traveling, here's an image, a still image of a tornado lofting these cars up. And this is not a very big tornado, but it's able to loft these cars up pretty easily. So consider delaying your trip if severe thunderstorms are in the forecast. If you have enough time, getting a sturdy building on the lowest floor, interior. Walk-in coolers make really good storm shelters in convenience stores. So keep that in mind if you have that ability. But don't try to outrun a tornado, especially in our region that's windy and curvy as the roads are. It's probably not going to work out too well unless you're on an interstate or something like that. And then find shelter in a ditch or culvert or low spot as a last resort. Highway overpasses are not good tornado shelters. And treat severe thunderstorm warnings seriously. This home was destroyed by straight line thunderstorm winds, not a tornado. So just like we talked about before with the microbursts, treat those severe thunderstorm warnings seriously, because severe thunderstorms can do damage just as intense as tornadoes. And as far as flooding goes, then unfortunately, even most flood fatalities or people who get swept away by floods occur most of the time that's on roads that they know very well. Water may be over that road and you think, well, it's not very deep, but again, you don't know what the condition of the road is underneath that water. Here's a classic example. Here's a time lapse. Took about 1.5 minutes for all this to occur, but here's this road covered over by water. The stream over here is actually being dammed up by the road. There's a culvert underneath here, and the road is overtopped here. And notice it's not very deep. You can see the yellow line. I might think you could get through that. Here's a couple seconds later. Notice the road starting to collapse, and finally the road collapsed, and that's what it looked like after a couple minutes. So that culvert was completely gone. So yes, you can see the yellow line could probably make it through that. However, the road would likely collapse on you as you started to drive over it. So don't drive through floodwaters, turn around, don't drown. And here's some more flood safety information. Only takes about 2 feet of flowing water to carry away most vehicles. So don't drive around road closed signs or barriers like this person's doing in their truck. They end up going off the edge here and needing to get rescued. So again, turn around, don't drown. And as a spotter, please provide as much specific location information as you can if you see flooding. Roads, intersections, creek names, any of that information will help us get that warning out much quicker. But if you do see lives being threatened, call 911 first, and then when you hang up the phone with them, call us and let us know about the flooding. Okay, so quiz time. There's our final quiz question. So out of all the options below, what is the safest in a tornado? What do you think? All right. Everybody's voted and everybody got that one right. Basement. Very good. Okay. So let's quickly talk about winter weather. Like I said, I think we're done with winter. We'll see. May get a little more snow at some point, maybe in the mountains, but hopefully we're done with it after February. The ice storms and the flooding, I'm done with it. But we do rely on spotters in winter. And if you can, like I said before, we don't have any automated equipment to tell us how much snow has fallen, unlike rain or temperature data. We've got stations that measure that for us. We need human beings to measure the snow for us to know exactly how much snow has fallen. And then we also need spotters and weather enthusiasts to report let us know it's snowing, sleeting, or freezing rain using that MPing app. That's the best way to get that information to us. But any occurrence of freezing rain is very important to us. We need to know about and those changing precipitation types. But as far as snow goes, if you can take a ruler, measure the snow on a picnic table or a porch railing, then do so and pass that on to us by one of our methods of reporting. We ask that you not measure in the grass because the grass can inflate your total. So if you do get snow, measure on something flat that's representative of the snow in the area. So that would be very helpful to us. So let's review real quick. This is what we need to know about. If you call our spotter hotline, tell us who you are, what weather is occurring, when did it happen, and where did it happen. We want to know about tornadoes. We want to know about funnel clouds. And again, if you think you see a funnel cloud, look for rotation and then look where it's pointing. Make sure you're not getting debris being kicked up. At that point, you would have a tornado. Wall clouds, rotation's key there. Wind or storm damage, even if it happened in the past, we want to know about it. Hail, we want to know about the largest stone you see, but any size hail I want to know about. And then flooding or heavy rainfall, of course, let us know about that. And then we talked about what to report in the winter. Snowfall amounts and any of that freezing or frozen precipitation, use that NPing app to let us know that that's occurring. Okay, now if you want additional information, there's a really neat website, weather.gov/jetstream. There is a lot of good information on this website for all ages, including Doppler radar, how to use Doppler radar. Really well-designed web page, and so I encourage you to go there if you're wanting more in-depth information. And then also there's a couple of online training modules through MetEd that you can access from our Weather Spotter page. And so you can go roll the Skywarn Spotter and Skywarn Spotter Convective Basics. That'll take you to these classes, and you can get more information on weather spotting there. There's my email if you need to contact me. So again, here's what's going to be provided the next step. So because of this platform, because it is online, what we're going to do is we're going to follow this up with an email in about an hour. And on that email, there will be an online form for you to register as a weather spotter for National Weather Service Charleston. If you're not in our service area, that's okay. You can go ahead and fill that out, and I'll forward your information on to the appropriate National Weather Service office. Most offices will accept spotters, even if they're trained in another forecast area or by another forecast office. So there's also going to be a survey in there. Fill that survey out. Let us know what you like or didn't like about the class. And then I will in turn, after you fill out the registered weather spotter form, I will in turn send you an email with our weather spotter hotline number and some other information. So I should be able to get that to you tomorrow if you fill out the form tonight or tomorrow morning. And then again, the feedback you provide is anonymous, but very much appreciated. And then if you do want a spotter certificate to print off to show that you took the class tonight, go to weather.gov/RLX/spotter certificate. And you can go in, you can put in your first and last name and then select the class, select tonight's class, and you'll be able to print a certificate like you see on your screen. So hopefully that works out for you. I do not see any questions. I'll stay on the line here for another 5 minutes or so. If there are any questions or anything you've ever wondered about, you want to ask, feel free to do that. But otherwise, that's all I've got. I really appreciate your attention tonight and that you joined us. And I hope you got some information out of it. And I hope you have a great evening. And again, I'll stay on here for about 5 more minutes to see if there's any questions. Otherwise, thank you all, and I hope you have a great night.